Hi, this is practice problem number 2 of this 5C balancing redox reactions in acidic solutions. So for this problem, the first thing I want to do is write a couple of half reactions. I've got MnO4 minus 1. That manganese is being reduced down to a plus 2. And I've got the oxalic acid. And my product is carbon dioxide. Next, I'll balance for mass. So the manganese is balanced, my carbons are not. I need to put a coefficient of 2 in front of that CO2. Next, I'll balance the oxygens by adding water to the side that needs more oxygens. So I'll put 4 waters on my product side. And in the second reaction, it looks like the oxygens are balanced. Now I'll balance the hydrogens by adding protons to the side that's lacking in hydrogens. So in the first reaction, I've got 8 hydrogens as products, so I'll add 8 protons to my reactants. And in the second equation, I need 2 hydrogen ions as products. Finally, we balance for charge, and it looks like in the first equation, in the reactant side, we have a total sum of positive 7, 8 protons plus the MnO4. And on the product side, we have a total charge of plus 2. So we'll add 5 electrons to the reactant side so that the reactant side and the product side have a total sum charge on each side of plus 2. In the second equation, we need to add 2 electrons to the product side. Now we'll just multiply both of these equations by small whole numbers so that the number of electrons lost equals the number of electrons gained. So the first equation will multiply by 2, the second by 5. So I'm going to rewrite these and then we'll add them together. Give myself a clean slate here. So I've got 2 times all of this gives me 10 electrons plus 16 protons plus 2 MnO4 minus yields 2 Mn plus 2 plus 8 waters. And in my second equation, I'll multiply everything by 5. So I've got 5 H2C2O4 yields 10 CO2 plus 10 protons plus 10 electrons. Now we add the 2 together. Electrons lost equal electrons gained, so we cancel those. I'll notice that I've got 16 protons versus 10 protons, so I can actually cancel out the 10 protons and just leave myself with 6 protons as reactants in my first equation. And none of the waters cancel at all. So now I'll just write down my final answer. So we'll start with the MnO4. I've got 2 MnO4s. Then in terms of the oxalic acids, I've got 5 of those. By the way, there's no significance to the order that I'm writing these in. I've got 6 protons. Sometimes I just like to go in the order that I received the problem, but it really doesn't make any difference. And then in terms of the product side, for the Mn, I've got 2 Mn plus 2. Plus, for the CO2, I've got 2 CO2s. Plus, oh, I'm so sorry. Got a little confused there. I've got 10 CO2s down here. Whoops. And then I've got 8 waters. So that should be balanced. Let's just double check. In terms of charge, we've got minus 2 plus 6 is a total charge of positive 4. On my product side, we have plus 4. In terms of the manganese, we've got 2 manganese, 2 manganese. We've got, in terms of oxygen, 8 oxygen plus another 20 is 28. Here we've got 28. So the oxygens balance. Hydrogens, we've got 10 plus 6 is 16. And on this product side, we've got 16. And in terms of carbon, we've got 10 carbons and 10 carbons. So that is a balanced equation.